now that you've done this whole ratio test, we're just gonna flip the switch, and we're now gonna talk about power series. Okay, so power series is gonna include a variable. All right, so we're just gonna officially put down what we just talked about. Okay, so we just reviewed that any geometric series is gonna converge if you have absolute value of r is less than 1. Any geometric power series will converge if the absolute value of r of x is less than 1. We talked about the convergence of a ratio test, and then we said that the limit had to do certain things. All right, what if, so I put a big like circle with a line through it, what if you don't have all positive terms? Because that was one of the requirements. Okay, what happens if you cannot guarantee it will be positive? Can we still do the ratio test? And the ratio test will work. It's just we have to have the absolute value then around that. L absolute value has to be less than 1. It will diverge if L absolute, well, without the absolute value, if L itself is greater than 1. And it will be inconclusive if L is equal to 0. So now we have, if you can't guarantee positivity in all the terms, then you have to limit the bounds between 1 and -1. So that's the only difference now is once we're adding a variable for a power series. So, and then I just want to review with you too just the terminology we've talked about. If it's geometric, whether it's a power series or a geometric series, those both have sums. The non-geometric ones, all we can tell is whether they converge or diverge. We can't give you the actual sum. Only a geometric series has an actual sum. So remember the vocab. We talk about words like radius. We talk about words like interval. We also talk about terms like center. So all of those terms you should be getting more comfortable with. All right, here we go. This is the thing for today. A power series will converge if L of x. So the limit is going to include x. Some of the things, I wrote it, I did this, but I think your book uses this notation instead, which is fine. Okay, we have R, and we have R of x, and we have L, and we have L of x. So let's just stick with that. Okay, this still will have a radius of convergence, and this still will have an interval of convergence, and it still will have a center. So all of those terms are still the same. So you should be able to eyeball these and drop them into categories, whether it's geometric or not, whether it's a power series or not. Okay? All right, so Kaylin, the first one, categorize it into whether it's going to be geometric or not geometric. Okay? Alex, can you do that one for us? Geometric or not geometric? Not sure? Not sure. Okay, Jonathan, what do you think? Geometric, not geometric?
Maybe geometric.
Maybe? Why?
Because both the numerator and the denominator are increasing. Well, it's to the exponent of n.
Okay, the exponent of n is a dead giveaway. So if you think it's geometric, what would you say is your r or your r of x?
X minus 2 cubed over 8.
Is?
R over x.
Not r of x.
Yeah.
All right, this is geometric, so we would classify it as that because the r of x is, and you look at these powers that are the dead giveaway, or should be the dead giveaway. So x minus 2 cubed over 8 is the r value because they're both being raised to the n power. Okay, so Alex, what do you think about the second one? Is it geometric or not?
No.
Why not?
Because it doesn't have R of x.
Okay, what does it have that keeps it from being an r of x? Why not?
Because there is only an n in the bottom.
Yeah, in the bottom, the denominator. Okay, the denominator has only an n. So this is non-geometric. And so we would need to find its limit approaching infinity. Okay, Kaylin, what do you think about the third one?
I think it would be geometric,
And-
because they're both raised times.
So what would, if you think it's geometric, what would the r or the r of x be?
R of x would be tan x over 3.
Yep. Okay, so tan of x over 3. And then the last one, it does have some stuff to the n power, but it doesn't have fully everything to the n power, so that would be a non-geometric as well. So in order for us to qualify. All right, so let's take a couple of these in particular. Determine the convergence of this series. Now, we cannot guarantee that this is always going to be positive because we don't know what x is. X is a variable that could represent any real number. If x was itself positive, we'd be guaranteed that all the terms would be positive. But if x is negative, it's going to alternate between being positive or negative. So positivity is not guaranteed. And it's also not geometric. So we have that if it's not geometric and we don't have positivity that's guaranteed. That doesn't mean we can't do the ratio test. We still can. We just have to be more careful with our result. So we'll apply the ratio test just like you were doing in your homework. So we're going to have n plus 1 x to the n plus 1 over 10 to the n plus 1. And then we'll multiply that by the reciprocal of the nth term. So 10 to the n over n, and then x to the n. And then we're going to order those or group those by sort of like associations. So you did this several times on your homework, where you'll have the n plus 1 grouped over the n term, and then you'll have the 10 to the n with the 10 to the n plus 1, and then finally you'll have x to the n plus 1 over x to the n, and then we reduce. In fact, because the limit, well, yeah, we'll go ahead and reduce. So we're going to end up with 1/10 pulled out to the front, and then we'll end up with x times x over 1 also pulled out to the front, and then the limit of the n plus 1 over n is all that we have left, which according to L'Hopital is going to have the value of 1. So I end up with x over 10. So my limit is not a number, my limit is an expression. And since positivity is not guaranteed, then we have to take this x over 10 and take its absolute value and set it less than 1. And then we solve that. So that leads to -1 is less than x over 10, which is less than 1. And that leads to an interval of convergence. So then we'll get -10 is less than x, which is less than +10. This is called the convergence interval. And so this series will converge if the values of x stay between 10 and -10. We don't know about equality yet. We don't know about what happens at 10 or at -10. But as long as it's between one of those, we have a convergence interval. Where is this centered? 0. Good. And the radius is? The radius is 10. If it's centered at 0, the radius is 10, and this is the convergence interval. Okay? So it's very similar to what you were doing. We're just adding x now. It's our power series. Okay, let's try another one. So here's the geometric one that we set up earlier. So we don't need to do the limit to this. We recognize the geometric series with the r of x to be x minus 2 cubed over 8. So we can go right to the definition of convergence, which would be setting it up as the absolute value of x minus 2 cubed over 8 is less than 1. So the definition of convergence, and then saying, okay, negative 1 is less than x minus 2 cubed over 8, which has to be less than 1. So then negative 8, less than x minus 2 cubed, less than positive 8. We cube root everything. The center is at 2. The radius is 2. So we're answering some of the questions here. If possible, find the interval of convergence, the radius of convergence. I can identify the center as well. So the center is 2. The radius is also 2. And the interval will be what I get when I add 2 to everything. So that would be 0 to 4. Finally, I need to come up with a function that is represented by the following series. So my function is an approximation of what would be equal to as the sum. So the function can be approximately recorded by our a sub 1 over 1 minus r. We haven't talked about what a sub 1 is, but Rain, if you were to find the first term, what would you plug in?
0.
And what would you get?
X minus 2, or pretty much 1.
Pretty much 1, yep. So 1, and then over 1 minus the r of x. So it'll be x minus 2 cubed over 8. And then mathematically, we want to clean that up. Kaylin, what's the quickest way to clean that up?
Turn 1 into 8 over 8, and subtract and
Mm-hmm.
then flip the fraction.
Yeah, and the same thing would happen if we multiplied all the terms by 8. So that would give me 8 over 8 minus x minus 2 cubed. And that's probably simplified far enough. That simple function is going to be the approximation for the series. Okay, so Edson, what's the advantage of being able to find a function that would represent the series? We've talked a little bit about some of those. Okay. So we did find what it converges to, which we can do with any geometric series. What's the advantage of being able to do that? What can we do with this f of x that we couldn't maybe do with in its original form?
Do like derivatives and antiderivatives?
Yes. Okay, we can do derivatives, we can do antiderivatives, and we can make graphs, which is a lot easier to do when you're in the approximation form, the function, than it is when it's in its series form. So that's the advantage of being able to do that. Okay, let's try another one. All right, Jonathan, what kind of series are we looking at here?
The non-geometric.
Mm-hmm. Non-geometric and non-positive. At least we're not sure it's positive because we've got the variable x in there. So we know for sure this is non-geometric. And it's probably not going to be positive either, depending on what x is. So then we have to tackle this with the ratio test. So then we'll take our limit and we'll set up our ratio test. So we'll have the quantity 3x minus 2 to the n plus 1 over n plus 1, and then multiplied by the reciprocal of the nth term. So you're probably getting pretty good at these. You should be able to get down to the point pretty quickly where we have 3x minus 2 times n over n plus 1. So simply just reducing those terms. And since the limit of n over n plus 1 using L'Hopital is going to be 1, we're left with our L of x is 3x minus 2. That's the limit when it's a function of x. So then we want to take the absolute value of 3x minus 2 and set it less than 1. And then work through the math on that. Okay, so once I get this, set this up between 1 and negative 1. All right, so Juliet, what would be the next step? I mean, I could think of two things I would do next. What would you do next?
I think I would divide by 3.
Okay, I would also. So dividing by 3 helps you to identify the center and the radius. If you just add 2, you're not going to see the center and the radius, but dividing by 3, we'll have negative 1/3. It's less than x minus 2/3, which is less than 1/3. So then we can identify the center to be 2/3. We can identify the radius to be 1/3. And then we can also identify the interval. And the interval will come then with the final step of adding 2/3 to everything. So the interval will be 1/3 to 1. So this non-geometric power series will converge as long as the values of x are between 1/3 and 1, but it is not possible to find a function to represent this series because it wasn't geometric in the first place. So there is no f of x possible as a representation of the sigma. Okay, not possible since it wasn't geometric. Not possible yet. There's a really smart guy named Taylor, and he came up with a way for us to do it. But yeah.
Will there ever be a case if it's like non-geometric but it's positive, or vice versa? It's non-positive but it's geometric, and which?
Okay, so if it's non-geometric, but you can guarantee it's going to be positive, then you don't need the absolute values.
Oh, okay.
And then you can would have just done 3x minus 2 is less than 1.
Oh.
Okay. All right. Yes, sir.
I still don't know that. How do we get y is not possible?
Why is it non-positive?
Not
Well-
possible.
Not possible.
Oh, because this is not geometric. In order to be geometric, if it's geometric, then the possibility is this formula here. But that formula only works for geometric series.
Okay, so y is non-positive.
Why is it non-positive? Okay, because at the beginning, we don't know what x is, and we don't know what n is. So suppose x was negative 1. Okay, then when you put x to be negative 1 in there, you would have negative 5. Now negative 5 to the n sometimes is positive, sometimes is negative, depending on what n value you have. So we can't guarantee that either. Okay. Now, if this had a 2, Alex, that's going to make it always positive, because when you square something, it will always be positive, no matter what. But I don't have a 2, so it's not going to be, we don't know. Okay, let's try again. Okay. All right, Christian, what do you think? What type are we looking at?
Geometric.
Okay, so if it's geometric, what are you going to go ahead and claim?
That r of x is equal to tan x over 3.
Yep. Okay, r of x is the tan of x over 3. So since it's geometric, we can go right to that the tangent of x over 3 absolute value needs to be less than 1, which means that the tangent of x over 3 has to be between 1 and negative 1. So we'll be able to center this at 0. Okay, so center is at 0. But my interval, I don't have yet until I apply the inverse tangent. So I'm going to have the inverse tangent of -3 is less than x, which has to be less than the inverse tangent of +3. All right, so we have our center to be 0, our radius, and our interval. Center 0, radius, tan inverse of 3, and then the interval of convergence is that one. So then, the f of x we should be able to come up with. So our f of x is going to be approximately equal to, because it's geometric, we want the first term. So my first term, if I plug 0 in, my first term in this case, again, is 1, and then 1 minus, and then tan of x over 3, or as Kaylin was helping us do, 3 over 3 minus tan x. So again, the advantage of having that is that's something that we could apply the derivative and integral rules to. We can make a graph of this. We could make a table of it. We can do a lot more things to it than we could in its series form. Okay, I think I only have one more that I wanted to go with. Yep, last one. All right, so I think you guys can tell it's not going to be geometric. And it's also not going to be positive. All right, so we'll jump to our limit using the ratio test. So I'll have n over n squared plus 1. And then I'll have x to the n plus 1. Hang on. Let me start over. Plugging in n plus 1 first. N plus 1 times x to the n plus 1 over 4 to the n plus 1 times quantity n plus 1 squared plus 1. So I have lots of n plus 1s everywhere, and I got to square it, so watch that you're doing that all correctly. Then we'll flip the nth term. All right, so n and x to the n. All right, so we get all that set. Then you want to rearrange your terms so that you're in an optimal state. So I'm going to put my 4n over my 4 to the n plus 1. I'm going to put my x to the n plus 1 over my x to the n. I'm going to put n plus 1 over n. And I'm going to put n squared plus 1 over n plus 1 squared plus 1. All right, so we got lots of terms going on there. The first of the couple reduce, then we have a limit. Okay, so Jonathan, what will the first term reduce to?
1/4.
Good job. Okay, Edson, the second one?
X.
All right, so I'll just say x over 4. Okay, and then Kaylin, the n plus 1 over n?
0,
Careful.
1,
Why?
I'm not sure.
Okay, so if you plug in infinity, what you'll get? Just for this part here.
It would be infinity or infinity.
Okay, which is indeterminate.
And then
Okay, so then take your derivatives. Just of that part.
it would just be
1 over 1. Okay, so that's going to be 1. All right, and then Rain, the last one.
Sorry, I didn't simplify it yet, but,
So if you plug in infinity,
it would be infinity over infinity.
Okay, and if you take your derivatives, it'll be,
It would be 2n over 2 times n plus 1.
okay, and that's gonna be
Still.
over infinity, so if you
2
take,
over- Maybe 2 over, whatever FOIL fill that is, or 2.
you said 2 times n over 2 times n plus 1.
2 over 2.
Yeah,
Yeah.
so it's
Okay.
still gonna be
1.
1. All right, great. After all that, all right, we got our 1. Okay, that's okay. Yep, so all that's gonna be 1. So then we have our absolute value of L of x has to be less than 1. So that means absolute value of x over 4 has to be less than 1. So that means -4 to +4 is my interval, my radius is 4, and my center is 4. And I can't find a function because it's not geometric.